LeetCode Problem 17, Letter Combinations of Phone Number. Hey everyone, this is KeyStrokes. I'm a senior software engineer at one of the FAANGs, and I like to make videos on LeetCode problems and programming puzzles and anything and everything about computer science. Today we'll take a look at LeetCode Problem 17, which is called Letter Combinations of Phone Number, and it's a medium difficulty problem. So let's take a look at the problem statement. We are given a string which has digits from 2 to 9, and each digit maps two characters like in a telephone button. On the left, we can see a telephone keypad here, where we can see where digit 2 maps to 3 characters A, B, and C, digit 3 maps to D, E, F, and so on. Now, our goal is to return all the possible combinations for the string that will be given. So let's take a look at the example 3 first, where the input digit is only 2, and 2 corresponds to 3 letters A, B, and C that we can see here. So the output basically becomes A, B, and C. Now, if we jump into example 1, we can see we had 2, but now 3 got added to it as well. So for 2, our answer was ABC. Now when you add 3 to it, we need to append D, E, and F to this array so that we have all possible combinations. So if we pick the first character, which is A, which corresponds to 2, and then add D, E, and F to it, then we get AD, AE, and AF. Similarly, next if we pick B and add DEF to it, we get BD, BE, and BF. And then if we pick C and add DEF to it, we get CD, CE, and CF. So for the string 2, 3, we get all of these possible outputs. So let's take a look at everything that you need to know to solve this problem. So you will need to know how to use loops, as we'll be iterating on several things. Then if you're interested in the recursive solution, then you need to know basics of recursion as well. And as for data structures, you'll need to know how to use arrays and how to use lists. So let's see how we can build an iterative solution, which is very similar to BFS. Okay, so on the right here, we have the digits and the corresponding characters that are possible for that digit. For example, for digit 2, the possible characters are A, B, C. For 3, it's D, E, F, and so on. So let's start with the most simple input, where the string had only one digit, let's say digit 2. Now for 2, we have 3 characters that we can see here, which is A, B, and C. And that's the only possible combination, and so this becomes our answer. Now let's say if we had to add 3 to the string as well. Then we have ABC from 2, and then we have DEF from 3, and we basically create all the possible combinations from them. And so we end up with A and D, which is AD, then A and E, which is AE, then A and F, which is AF. Then we do the same for BD, we get BD, then BE, then we get BF, and similarly CD, CD, then CE, and then CF. And then this becomes our answer. And this is what we need to do for BFS solution, exactly how we did it right now. We pick the first digit from the given string, which is 2, then we add it to our list, which is, let's say, A, B, and C. Now we pick our next digit, which is 3, and the corresponding digits now become D, E, and F. Then we basically pick each element from our current list that we have. So let's start with A, and then we pick each of the new characters that we can get from the new digit that we are working on, which is 3 in this case, and then we add them all to a new list. So basically we pick A first, then we pick D and add it to a new list, then we pick E, then we add A and E to the new list, and then we do it for the F, so A and F. Now that the new digit characters are exhausted, we go to the next item in our list, which is B now, and then we do the same. Now we do B and D, so BD, then B and E, so BE, then B and F. Now B is done, so we move on to our next item in the list, which is C. So we do CD, then CE, and CF. And then basically this becomes our new list, and we discard the previous list that we had. So now let's say if there was another character in the string. So let's say if there was a 4 here, then for digit 4, our list of new characters become G, H, and I. And now we do the same thing. Now because this is our new list, we pick the first item from the list, and then we append each of these characters to this first item. So we basically get ADG, then ADH, then ADI. Now AD is done, so we move on to the next one in the list, which is AE, and do the same again. So we get AEG, AEH, AEI, and we're done with this. Then we move on to AF, so we get AFG, AFH, AFI, and then we just keep doing it until all of these elements are exhausted from our current combination list that we have. And once we create this new list replaces our current list that we had, and now this list gives us the combinations for all of these 3 strings. And that's all there is to BFS. We process one digit at a time and keep appending to it. A good visualization could be, let's say for a string 2 and 3, we start with an empty string and to it we append all the characters of 2 first, which will be A, B, and C. Then we pick the characters for digit 3, and then we append it to all of these 3 characters that we have. So for 3 we have D, E, and F. So to A we add D, which becomes AD, then AE, then AF. Similarly BD, BE, BF, and then CD, CE, and CF. And if we add another digit here, let's say 4, then we add the 3 digit of 4, that is GHI, to each of these as well. So this just keeps growing in a breadth first search fashion, and in the end you end up with all of the combinations that are possible, and you just keep doing it for all the digits that are given to you in the input string. And that's all there is to constructing all the combinations using a breadth first search pattern. Okay, so here's the pseudocode for the BFS-like iterative solution. First, we start with getting the digits as the input, which is a string that consists of digits from 2 to 9. And then we add a base check. If the string is empty, basically its length is 0, then we return an empty list. Otherwise, we start by creating an array, which is called digit to char, which basically stores for a given digit what are the possible characters for that specific digit. So if we had to know for digit 2 what are the possible characters, we'll just access the second index of this variable. Then we create a new list called combinations, which is where we store our results, and we prime it by adding an empty string to it just so that we can start our iteration process. Now for each of the digit in the digits string that was given to us, we first figure out what are the characters for a digit by using the digit to character array that we created up here, and we basically pass the digit that we are working with. Now this chars for digit stores all the characters for that given digit. Then we create a new list called new combinations, and this is where we'll store our new set of results after we go through this for loop. So we start by iterating on our current combinations list that we have that was created up here. Now for each of the combination that we have evaluated so far in the combinations list, we do the following. We basically pick each character for the given button or the given digit that we are working on, and then we add it to the combination and then add this new string that we created to this new combinations list that we created up here. So basically take every element in the combination and take every character that we are working with for the given digit and append it to the combinations we have had so far and add them all to this new combinations. Now after this for loop is done, new combinations contain all of the combinations that we are interested in after we have worked on the new digit. So we can basically replace our combinations with new combinations by just variable reassignment. Now after we have processed all the digits in the string that was given to us, our combinations will contain all the possible combinations that could be created using those digits. And so we just return this combinations as part of the response. If this is confusing, then please don't worry. As we code this out, this will make much more sense. Okay, so let's jump into our IDE and code the solution out. Okay, so here we have LeetCode, and this is how the method looks like for the problem that we're trying to solve. So copying this, I'm going to IntelliJ, and I have a solutions class here, and I'll just paste the function here. So the method name is LeetCombination, which takes in an input as a string, and we need to return a list of strings. So let's start by adding a simple corner case where if the digits, if its length is 0, then there are no combinations to form. So we can simply return an empty array, and we can do return new empty array list. Otherwise, let's first start by creating an array that maps each digit to the possible characters that it can have. So we can do final char, it'll be a 2D array, and let's call it digit to char. And in here for the 0th index, we know that there are no characters, so it can be empty. For digit 1, it should again be empty, but for digit 2, this should be A, B, and C. And let me populate this for all the other digits, and I'll be right back. Okay, so now we have our digit to character 2D array. Now let's create a new list that will store all of our combinations. So let's create a list of string, and let's call it combos, and this could be a new array list. Now to this combos, we'll add an empty string just so that we can kickstart our for loop. So let me do combos.add and an empty string. Now let's start by iterating on the input digits that we have. So for that we can do for char digit in the digit string that was given to us. So digits dot to character array. So now we have our individual digits. Now let's grab all the characters that are possible for this digit. So we can do final char and chars for digit equal to, we take this digit to char array and then we grab this digit. But remember, this digit is a character. So we need to map that character to a numerical index from 0 to 9. And for that we can do character dot get numerical value and pass digit to it. So passing digit to it, and now we should have all the characters for the current digit that we are working on. Now we need a place to store all the new combinations that we'll be creating. So we'll create a new array list. So copying this, and let's call it new combos. And now we'll start iterating on all the combos that we know so far. So we can do combos.forEach, and we can call it current combo. Now for each of the combination that we have so far, we want to append all the new characters for the digit that we are working on. So let's do a for each on this characters for digit as well. So doing for final char, let's call it digit char of chars for digit, and we'll basically push a new combination to new combos. So we'll do add, and to this we'll add the current combo that we have plus this new digit character. So basically we took all the combos that we have in this array list and then iterated on all the characters for the current digit, and then we appended it to this new combos that we have. So if combos had, let's say, A, B, and C, and if char for digit had D, E, and F, then in the end we'll basically have A, D, A, E, A, F, similarly B, D, B, E, and B, F, then C, D, C, E, and C, F. Now after this is done, we will replace these combos with this new combo that we have. So we can simply do combos equal to new combos, because now new combos have the latest combinations that we have after processing each digit. Now after all the digits are processed, combos will have all the combinations, and we can simply return combos. So return combos, and that should be it. Now I have this main class here which uses the solution class and has some of the base cases from LeetCode. So let's run this and see if our solution works. And we can see it's all correct answers here. So going back to our solution class and copying all of this and jumping onto LeetCode and pasting this solution here. And now let's run this for the base cases on LeetCode. And yes, they were accepted for the base test cases. Now let's submit this so that it actually runs for the real test cases. Yeah, and looks like our solution was accepted, and it beats around 43% of the solutions. With this problem statement, I think we can build a recursive DFS-like solution as well. Let's brainstorm the solution and see if it's possible. Okay, so here on the right, we have the digits and the corresponding characters that map to those digits. For example, for digit 2, there are 3 possible characters for it, which is ABC. For digit 3, it could be DEF, and so on. So let's start with a very simple input of, let's say, 2. So the first thing we'll do is, let's say, create a list where we can store all of our combinations. So let's just use this to store our responses right here. Now for 2, the corresponding characters will be A, B, and C. And we need to append these A, B, and C to some string. So let's keep a track of a string that is shared across all the recursion that we'll be doing. So let's call it current string. So to start with, we have an empty current string. Now before we start our recursion, we need to have a base condition. Our base condition can be when the length of the current string is equal to the length of the input string that was given to us, then we can add that combination to our list. And that's because there will be no other characters to append when the current string and the input string that was given to us, they are of the same size. So let's see. We start with the first character that can be represented by this digit 2, which is A. And at this point, our current string was basically empty. There was nothing in there. Now, when we make the recursion call, we append A to this current string. And in the recursion call, this current string basically becomes A. Now, if we check our base case, the length of A is equal to the length of the input string that we had, which was 2. So we add A to our list. And because our base condition is satisfied, we return the control back to the caller, where we know this iteration was running. Now we move on to the next character, which is B. Now for B, we do another recursion call. And as part of the recursion call, we append B to this empty string. So our current string now becomes B. Now again, B has the same size as 2 and it satisfies our base case. So we add B to our list of combinations. And now again, control is given back. Now we move on to the third character, which is C, and we start our recursion again. Now C gets appended to this empty string again, and our current string becomes C. Now C and 2, they are of the same length, so C gets added to our list, and the control is then returned back again. Now after C, there is no other character to process, so this ends our recursion, and then our answer becomes A, B, and C. So this was the most simple input. So let's try with an input of size 2. So let's say if we were given 2 and 3, how will this look like? So we start our recursion call where we keep our current string as empty, and in the recursion call, we pick the first character of our digit string, which is 2. Now corresponding to this 2, we know there are 3 characters possible, which are A, B, and C. Now we start iterating on these A, B, and C. So we grab A, do a recursion call, and append this A to the current string. And so in the next function call, our current string becomes A. And while we do that, we also pass our input string, which is 2 and 3. And this time we move on to the next digit that we need to work on, which is 3 in this case, because previously we worked on 2. Now here, if we check our base case, the length of A is not equal to length of the input that we have, which is 2, 3. So we still keep going with our recursion. Now in this case, we find all the characters for the digit 3, which is D, E, and F. And now we start iterating on them. So we grab D, and then we start a recursion again. And we also append D to the current string. So our current string now becomes A, D, and then our original 2, 3 input gets passed. But now this time we say process on the next character in the input string, which is not valid. And we won't even reach that point because first we run our base condition where we check if the size of the current string is equal to the size of the input string, which is true. So in this case, we just add AD to our final list of combinations. And because our base condition satisfies, this just returns the control back to the previous caller in the recursion. Now D is processed and its recursion call is over. So now the next character that we work on is E. Now E triggers the recursive process again. So it appends E to the current string that we have as A. So our current string now becomes A and E. Now A and E again satisfy the base condition of the current string and the input string to have the same size. So AE gets added to our combinations. Now the control again goes back and this recursion is done. Now this time we move on to the next character, which is F. So a new recursion call is made. F is added to A. So we get AF, and this satisfies the base condition as well. So AF gets added to our final combination list. Now after this, AF returns the control back again, and this recursion step is done. Now because F was finished as well and there are no other characters to work on, the control is again sent back to the parent caller, in this case where we were processing on this digit 2, and now we are done with processing A. Now over here we move on to the next character, which is B, and then we run the exact same thing, but this time our current string becomes B instead of A. And then we do the same thing, we add D to it, then we add E to it, and then we add F to it, and then B will be done, and then we'll move on to C, and it will do the same thing of adding CD, CE, and CF. So to visualize it as a tree, let's say if our input was 2 and 3, then we start with an empty string, and then we add the first character which are possible for this digit 2, and that character would be A, because 2 can have A, B, C, and 3 can have D, E, and F. So we start with A, then we go to the next digit in our input string, which is 3, and then we pick its first character, which is D. So we add D to it, which makes the final string of AD. Then we add E to it, which makes it AE. And let me just add these just so that it's more clear. So plus A there, we have plus D here, plus E here, and then we do plus F, which gives you AF. And then the control goes back over here. Now that all DEF was done and A was done, we work on the next character, which is B. So we do plus B. And now again we go back to 3 and then start adding D, E, and F to B. So this becomes B. Then we add D to it, so it becomes BD. Then plus E gives you BE, gives you plus F, which will give you BF, and so on. So we basically start from nothing and then go as deep as possible, and then we backtrack, and then we go to the next possible string, and then we backtrack and to the next character, and then we backtrack all the way to the top, and then go to the next character, and basically follow a DFS approach. I know this might sound a little complicated, but try to do it on your own, try to do some of the dry runs, and this will make much more sense. The more dry runs you do, the easier it gets to visualize recursion in your mind, and then the solution just comes to you intuitively. Okay, so here's the pseudocode for the recursive DFS-like solution. We get the input in digits, which is a string consisting of the digits 2 to 9, and then we add a base condition where if the digit string is empty, then we just return an empty list. Then we create a digit to char array where each index of the array represents what are the possible characters using that digit. For example, here for index 2, the possible characters are A, B, and C. Now we create a new list, combinations, which will store all of the combinations that are possible. And then we call this append function, which will be our recursion function. To this, we pass our digit to character map that we created up here, the combinations list that we created here, and we pass all of the digits that we know of we just convert it to an array so that we can iterate on it easily. And then we pass a 0, which represents the current position that we are working on in this digits array. And then we pass an empty string, which basically tracks the string that we have formed so far. So let's see how does the recursive function look like. So just like how we called the append function here, we can see we taken several inputs here. One is digit to char array, then we have combinations, which will store all the combinations that will form. Then we have the digits array, which was given to us as an input as a string. And then we have the current digit position, which basically is the current position in this digits array. And then the current string is the current combination we have formed so far. So for any recursive function, let's talk about the base condition first. If the current digit position is equal to the digits.length, that means we have used all the digits that were possible, that was given to us as the input, and the string that we have formed so far is one of the combinations that we're interested in. So we just add this current string to our combinations and then we return back, as there are no other digits for which we need to form the combination. Otherwise, we use the current digit position and digits to get the current digit that we are working with, and then use digit to character variable to figure out all the characters for the current digit, which we store in chars for digit variable. Now for each of the character in this chars for digit, we basically call our recursive function. The first 3 arguments remain the same, but the last 2 arguments change. For the first one, we basically move our position in the digits by 1. That is, we want to start working on the next digit that was given to us. And as we are working on the next digit, we append one of the characters that we have from our for loop and append it to the current string that we had so far. So this basically follows the depth first approach, where it picks one character for every digit, adds it to the string, and then it backtracks, adds the next character, and just keeps doing that until it has exhausted all the possible combinations for the digits and its corresponding available characters. And if this is confusing, try to write on the code and you'll quickly end up with a tree structure, and you'll see how this exactly looks like a DFS. And it might make more sense as we code this out. Okay, so we can jump into our IDE and code the solution. But before we do that, if you've been liking the explanation so far, please don't forget to like the video and to subscribe to my channel. And you can show me your support by buying me some coffee and joining me on Patreon. And you can also have consultation with me through one-on-ones, where I can help you learn how to code, help you with interview preparations, and various computer science topics like data structures, algorithms, and basically any technologies. And I can also help you on your project ideas and how to execute them, including all the new hype ChatGPT and all the new machine learning integrations, and basically anything and everything about computer science. So please feel free to fill out this form, and you can find all the links in the description. Okay, so here's LeetCode, and this is how the function signature looks like. And I have IntelliJ here with the same function signature, where it takes in a string input called digits, and we expect to return a list of strings, which will be all the possible combinations. Here I also have this 2D array digit to character, where each index represents the digit and the value in there represents the possible characters. So for 0 and 1, there are no possible characters. For 2, the possible characters are A, B, C, and so on. So let's add a base case first. If digits, if its length is 0, that means it's an empty string. So we can just return an empty list, as there are no possible combinations here. Otherwise, let's create a new list. Let's call it a list of strings, and let's call it combos, and that will be a new array list, and we'll basically return this combos back. Now we need to create our recursive function and call it right here. So let's first define our recursion function. So let's create a private method. Let's call it append, and this will take a couple of arguments. So the first argument can be this digit to char. Then the next argument can be this list of combos, where we can keep pushing new strings to it. And then we can also take this string digits as the input. But instead of taking this as a string here, maybe we can make this as a character array. And because it's an array, we should also track what index we are currently processing on this digit. And we can do that using a new variable. Let's call it current digit position. And then we'll also have a string builder, which will track the string that we have been building so far as we execute our depth first search. So let's call it current string. Let me make this final as well. Now let's add a base case first. Our base case will basically be if the current digit position, if it's equal to the length of the digits, that would mean we have processed all of the digits. And then all we should do is build a string and add it to the combos. So let's see how that looks like. So the condition will be current digit position is equal to digits.length. Then we'll basically do combos.add and then current string.toString. And then we return back to the parent caller. So this is our base case. Now, if our base case is not satisfied, the first thing we should do is get all the characters for the current digit. So current digit will be digits and then this index, current digit position. So we can do character current digit, but this current digit is a character. So we need to convert this current digit into the numerical value. And we can do that as current digit, let's say num equal to character dot get numerical value, and we pass current digit to it. Now that we have current digit num, we can access digit to char and pass current digit to num to it, and that should give us all the characters for this current digit. So let's call it chars for digit, and these are all the characters for the current digit. Now let's start to iterate on them. So for final char digit char of chars for digit. Now in here we need to call our recursion function again. So let's call append, and to this our digit to char will remain the same, nothing changes there. Then we have the combos, which will again be passed as reference. Then we have our digits, which doesn't change. But for current digit position, now we want to move on to the next character in the digits. So we can simply pass current digit position plus 1. Now the current string that we are passing on as well, this should append the current character that we have. So we can simply do current string dot append, and we can append the current character for the digit that we have. Now this calls it recursively, and when the control comes back to us, we need to undo this append thing that we did, because current string is a builder and anything we do here will still retain here. And to do that, we can simply do current string dot delete character at, and we just need to delete the last character because that's where the character got appended to. So we can do current string dot length -1. And that's all there is to this recursive function. So let's see how we'll invoke it. So going up here, let's see append. To this we pass digit to characters as it is from here. Then we have our combos list. Then we pass our digits. So we can do digits, which is a string, to character array. And then we want a value for current digit position, which will be 0 because we want to start with the first digit. And then for the string builder, we have no string, so we start with an empty string, and so we give it an empty string builder. And I have a main class here which has a bunch of base cases from LeetCode, which uses the solution class. So let's run this and see if our solution works. And yes, we see all our correct answers here. So let's copy our solution and try to put this on LeetCode. So copying all of this and jumping onto LeetCode and replacing what we have here. And let's run it again for the base cases just to make sure everything is fine here. And yes, it was accepted. So now let's actually submit this and let it run for the actual test cases and see how it performs. And yes, we can see it beats 100% of the solution, and LeetCode is happy with our solution. Okay, so that's all I had for this video. I hope it was helpful, and if it was, then please don't forget to like the video and to subscribe to my channel. And you can follow me on Twitter, and you can show me your support by buying me some coffee, joining me on Patreon, and please feel free to reach out to me for consultations by filling out the one-on-one form that you can find in the description. I'm working on the next video and it should be coming out soon. In the meantime, please check out this video on your screen and try to solve this problem. Thank you so much for joining in. I'll see you next time.